the things that I find so inspiring about your story and being around kind of your energy is that science is about curiosity, right? And science is about innovation and discovering new things. And in your journey, you looked around and you kind of went, yeah, today is great. Like what is possible today is fantastic and it's wonderful and it's a privilege to be able to help people the way I do. But what if tomorrow could be better? And that's just resonated for me so much. Like, what if we could make tomorrow better? What if each of us could stand up and make a contribution to help everybody move tomorrow into a better place? So for you, you've been doing this your whole career, but you're perhaps most famous for co-inventing spray-on skin. Can you tell us a little bit more about what that is and how you came to be in this place where you can help so many thousands of people around the world?
Well, the spray-on skin is a spray-on skin cells. So what we do is we take skin cells from a part of your body that's not injured, and we split them all apart. We kind of with an enzyme and with mechanical scraping, we get all those individual cells that are normally behaving beautifully in your non-injured skin, and we spray them over the wound elsewhere on your body. And so we change the pattern of healing and try and get by putting new cells in there, we try and get the healing going faster. We use it on its own with other technologies and as traditional techniques as well. But it's all about getting the wound healed the fastest we can, because then we can reduce the pain, reduce infection, reduce the scarring. It's all driven about the time to healing and using our body, our body's capacity to heal. Elsewhere, our skin turns over all the time. Every 6 to 8 weeks, we're shedding the surface and it's repairing itself all the time. Well, it's harvesting that engine room and putting those cells in an area where they're going, I need help.
Just it's amazing. And at the time when you were sitting, your co-inventor Murray Stoner, you were sitting together and you were thinking, okay, how can we heal people faster? How can we heal people better? Why don't we go to Bunnings? Like that spins me out. Like, why don't we go to like buy some spray on, spray on deodorant and spray on oil and spray on paint and test these things out and see if we can spray on skin. I mean, that is such a wacky idea. How did you come to that?
Well, we were growing skin cells into sheets, and the sheets were like really fragile and really difficult to handle. And we started to see that if the sheets had holes in, that we thought, oh, should we use that? But then it would heal quicker than the sheets that were solid, and it blistered less. And we thought, oh, this is interesting. And so then we started say, well, maybe we could put the cells on before they become a sheet in a solution. And we made dressings into giant blisters, and we put the cells in the blisters and all sorts of different things. And then one day we just said, oh, we should just spray this on. Well, it was Marie or I, we can't remember. It's like, whoa, that's a good idea. And so we went to the art store, to Jackson's art store in this Rockaby Road in Perth, and looked at all the different airbrushing. I went to the chemist, the pharmacy, and everything that was sprayed, and we just took the nozzles off, and then went into the hospital and the anesthetic trolley and all the different storerooms in the hospital, anything that sprayed. So we got every kind of spray device we could, and then we did the experiment. Let's grow some skin cells, put them through the various nozzle systems, and see which is best. And that's what we did.
It's amazing. And which one was best? Which did you find?
It was an Italian mouth freshener from the chemist that was best, and it was clips. We can clip it onto a standard hospital syringe. We could put it through the autoclave so that we could make sure it was sterilized, and it was still functional. And now that company who made the nozzle that fit on the bottle, because all these things are so interestingly complicated. Yeah, we just buy a bottle and we thought, oh, that nozzle looks interesting. And then we dissect it. You have to do the experiments. You know, cut the nozzle up, look what's inside, make sure there's nothing that's like could be a problem, and then do the experiment, set up the experiment, write all in your lab book, right? This nozzle A, B, C, D, cells number 1, 2, 3, 4, and then grow them and then take the results. And so that nozzle, when we clipped it onto a standard syringe, was the best. Over 90% of the cells survived coming through that system. And so that was when we contacted the company, because you can't contact the company that makes the mouth freshener because they buy the bottles and the nozzles from somebody else, and so on it goes. And so now those nozzles are produced specifically for the kit that is used around the world.
Amazing. And so you driving to Jackson's and the chemist and writing up that little experiment has led to the situation now where people who need their skin to heal around the world can benefit from your invention. That's amazing. That's so cool.
When I look at the kit and I go, wow, did we really do that? Yeah, because a young scientist and a young surgeon, but it was a lot of hard work, because what we did then, once we realized we could spray the skin cells on, well, how do we put the capacity to harvest the skin cells in everybody's hands? So that's the kit. So then we looked at what was the minimum number of steps to keep it simple so you can be reliable, and then worked each step out, and then how we put it together. And even you find out things like molding plastic into a box. You've got to mold a kind of plastic that doesn't change while it's being molded, or doesn't change while it's being sterilized, that doesn't affect the cells, that's not toxic to the human, and all these different things. So every little part of it was an experiment and a series of experiments. And then the enzyme we use, we had to, the source of the enzyme and the certification, it comes with certificates and everything, and then you have to make it warm, so we had to have electronics, and we have to connect with our friends who in Go Medical, who are doing different syringe driving pumps, and said, well, we need this heated to this temperature in this time frame, and with this, we need a red and a green light so we know it's ready. Can you do that for us, please? Yeah. So there's, in the kit, there's biological aspects, there's the cells and the enzyme, there's electronics with the enzyme temperature, there's filtering, so that we filter all the debris, because the skin has a framework and we take the cells off the framework, and it doesn't spray if you've got a little bit of, it clogs up if you've got all the frame, like the protein framework still in there, so we filter that out and then we spray it on. So that's a whole series of experiments. You have to be methodical and all, but you've got to be inventive, and you got to work out who's going to help you, because you can't do it all by yourself. And that's what, getting the teams together, that's what makes it fun as well, because you can start to share ideas and see what other people are doing. And then you go, oh, I thought we were going to do it that way. But actually, your way's better, or a way, like using your ideas and my ideas, we can come together to get a better solution. So I'm a great believer that more heads are better than sort of single head.
And I think that's the way science is going, isn't it? Like to solve a problem, we work so much better in teams. We've got so much diversity and curiosity and imagination all coming together. And your example of spray on skin is such a great example of that, where everybody brought their area of expertise together and you've got this incredible product.